Good afternoon. Today I will show you how to create a server in Phoenix. So this is a last assignment for a laboratory. And the Phoenix operating system uses a microkernel, and the microkernel handles only what is necessary for system to run, including, for example, thread scheduling. And servers is responsible to handle the rest. So now I show you how to create a server in Phoenix. A very simple server is included as an example in a Phoenix. So I start from this and show you the another server, change the letter to uppercase. So look that in a Phoenix RTOS project folder, when we clone the repository, there is in a user, there is a application server demo. This is a normal application, this is a server, so the server is normal user application, and this application is run in a Phoenix. It creates a special file in a dev folder, and using this file we can write to this file and read to this file, and this is managed by the server. So now I show you how to create the server. We start from a main C file, and I show you first the main function. So look, in here is a function main, and to communicate process with another process, the Phoenix use a message. So it's possible to send a messages between processes. The address of the message is specified by using a port. So we need to create a port, and we can send the message to the port. And in this application, in this server, we create a port. And additionally, for a port, we create an object ID. So look that in here, we create the object ID. The object ID consists of two parts. It's a ID and a port. The port is a place when to receive a message, and the ID is a internal identifier inside the server, and we can choose a value of the ID. It's our decision. And look that if we create the object ID, we set the ID to 0, and we create the port. And we assign the port value to the object ID structure. And next, we need to register a new special file. So we use a create dev function to create a server demo special file. This file is created in a dev folder, and this file is associated with the object ID. So the object ID consists of the port and ID. If we need to create more than one special file by the server, it's possible to use the same port for these 2, 3, or 4 files, but we need to create more than one object ID with different ID. So look that I can add the code. It's a object ID type, and it will be object ID second. And look, after creating the port, I can create the second object ID. So object ID second port should be the same. So it's done, and I need to create a new ID, because for a first object ID I use the ID 0, so now I use the ID 1. I can choose a different value. So look that now I have two object IDs. object ID and object ID 2. And look that using the object ID, I associate with object ID with a special file. So this function create a special file in a dev folder and associate with that object ID. And next I remove the unnecessary code. So this is not necessary. And look what I do next. After creating a special file, I create in this server demo the one special file is created. So next we execute a message loop. It's an infinite loop when we read a messages from a port associated with that object ID and perform an action depending on the message. If we use a special file, we receive a message. This is a specific for a file, so it will be open, close, read, and write. And look that the server message loop is a function defined in this program. So I show you that function now. This is a server message loop. And the parameter is an object ID. It's a pointer to the object ID, so I have access to the port and to the ID. It's two parts of the object ID. And first I need to, in a loop, I need to receive a messages. So look that in here is an infinite loop, and first we read a message. So we call the message receive. It's a Phoenix function from Phoenix library, and we read the message from a port. So we use the port associated with the object ID, associated with this special file, and we pass a pointer to the message struct and to the variable response ID. So this message receive function fill in the message and response ID. The response ID is used when we answer to that message, send the response. And the message is filled in with the data of the message, and we should check the message type and perform the appropriate action. So look that the message is declared in here, and this is a response ID. And look that next we try to check the message type. The one part of the message, one field in the message, is a type. So there are few predefined types. If we use a special file, we have a 4 interesting predefined message: open, close, read, and write. This constants is defined in a include file. So I show you this for a moment. And if the message is an open, so the client asks the server to open a file. So the server should handle this operation and return the response. In this field, we return the value or the negative value indicate an error. So look that after perform the correct operation, so I implement in this file there is a few functions implement the open, close, read, and write operation. So for a moment I show you the implementation of these files, and look at the end we send the response to that message. So we use the same port, we pass a pointer to the message because in the message struct we maybe insert the data, if for example it's a read from a file, and we need to pass the response ID. And look what is in a message. this variable type is that one. So I show the definition of that message. This is in a Phoenix RTOS kernel in an include directory, and here's a message H file. And look that there for file operations are defined to few constants. These are message types. For if we use a special file, it's a open, close, read and write. This for is interesting for us. So we handle only these 4 messages. So the system, if there is an operation on the special file, the system send one of this type message to the server, and server should handle that. And the message consists of 2 parts. It's an input and output part. And this is a type PID. This is a PID of the PID and the priority of the sending process. And look that in the input part there is a union. So there is a different parts, different fields for different messages. For open, close, read, write. For read, write is more interesting because this is a len. It's a number of values to read or write. And look, then additionally in the input part is a size and data. This is a buffer. So the data is a pointer to the buffer in the memory, and a size is a size of this buffer. So when the message is sent, so the sending process pass a buffer to as a part of the message, and the operating system in the virtual memory of the receiving process create a buffer, allocate a buffer, and copy the data into that buffer, and this is a pointer to that buffer. So the buffer is in a different address space, but the buffer consists the same data, and the size is the size of that buffer. In the outward part, it's an O, so there is the same size and data. So the process which responds to the message moved the data into that buffer, and this is copied to the correct place. So it will be available for in a process which send a message as a response. Okay, so now we're back to the code of the server, and look that first we receive a message. So we read a message from a port, and this function fill in the message and fill in the response ID. If there is no message, with this function wait for a available message. And so it's a blocking function. And look that next, because we interesting only with operation on a special file, so the message type can be open, close, read and write. In the open and close, we call the server handle open and server handle close, and pass as a parameter the object ID. So the object ID identifies the special file, because the special file is associated with an object ID, but the port can be used for more than one object ID. And look that the open and close function, this is a handle open and handle close. So we return 0 that everything is correct, so it's possible to open and close the file correctly. And we do nothing because always it's possible to open and close the special file. And the next two messages is read and write. So look that in a read, we pass as a parameter object ID. This identifies the special file, and we pass the, if it's a read, so we pass a message O data and message O size. So this is a buffer when the function should store the read data. And if we end this read function, handle read, return the number of bytes read from a file. So we assign this to that field in a message. The negative value indicate an error. And look that if it's a write, so we pass the object ID, this identifies the special file, and we need to use the input data because we need to save this data into the special file. And we return the value that is a number of bytes written to a file. And look how we implement these two operations, the read and write. Look, this is a read. Read is very, very simple. So in these two cases, we print a diagnostic message with information what happens. So this is in here, it's print on the console. And look that if it's a read, so we read the data, fill in the buffer with X character. So this is an infinite file with a X inside. And we return the len. So the len is, look, is a parameter, it's a number of bytes to read from a file. If we try to write to a file, it's a request to write to a file, so we print the diagnostic message on the console, and look that now we print the received data. So this is a function which print all received characters. So we print that information on the console, and we return that this data is written into the special file. So now I show you how to run this program and how it works. To do that, we need a console. So this is the original version of the source code. I have in a Phoenix RTOS project. So first I built the image of the system. And look that the server demo is maybe first I do one additional thing. I stop this because there is no, this is an unsafe file. Because I modify this file, maybe it's better to, in a source. Okay, so it's not possible to handle this. Okay, so now I try to build a disk image again. And next I run the Phoenix operating system in a QEMU and show you that there is a server demo special file in dev folder. And next I show you how it works. So I try to read and write from this file. Next I run QEMU. Okay, it's done. And look, if I display the dev folder, look that here is a server demo special file. And now I try to write some information into that file. So it's a cat command, A, B, C, D, E, F, and send this to the dev server demo special file. And look that it's done. Okay, and now I try to echo. Oh, sorry, I made a mistake. So I need to echo this and send this to the special file. Now it will be correct. Look, that is a message from a server. The server displays the diagnostic message and data is received by the server. And now I try to read the information from the special file. So use a cat command, dev and server demo. Look that now I receive a few X characters because this is an infinite file, so I need to use a Ctrl+C to stop them. And the diagnostic information was displayed on the console, and the buffer consists only the X. And look that that server, if I execute the ps command, look that the server demo is running. So this process is running in a background. And you can configure that in a target. It's a build project for this architecture. And look that in here I try to find the server demo. Look, in here is a line that start that server demo at the system startup. So this server is started when the server operating system is started. So I comment this line, save this, and now show you that what happens if I build the disk image and start the system again. Because I remove this line, so the server doesn't start at the beginning. And I try to start it manually. So to do that, I need the additional console. So I create a new console. Okay. So now I start the Phoenix. It's done. So look, if I execute the ps command, there is no server demo program because I remove the configuration from a configuration line which is responsible to start that program. And look that there is no special file server demo in a dev folder. And now I try to start this server manually. So first I connect telnet connect to the local host. I connect to the Phoenix remotely because I need the second console. It's done. So look, there is no server demo. And now I start from a USR bin, start the server demo program. Look that this program is started. It's a normal application. If I execute PS, look that the server demo is started now. So it should be visible somewhere. And look that now I try to display the context of the dev environment. So it's a server demo special file exists in a file system. And of course, it's possible to send the free characters into that file. Look that this is a diagnostic message. So it works. And if I cut, so I try to read from this file. So look that I read the till X characters, because this is an infinite loop. If I send the message to read from a file, the server responds the few X. So I stop this. Okay, so this is a first example. Maybe exit. Okay, something is wrong, so I close the console and I close the Phoenix. Okay, and now I show you a different example. It's not included in a Phoenix. So it's a example that use a one special file and use a buffer. If you send the data into that file, it is stored in a buffer and converted into the uppercase. And if we read that text. So first I need to discard the changes. Okay, and I switch to the different branch. It's a server uppercase. So look that I modify the configuration script. So I start the server uppercase at the system startup. So my program will be started when I run the Phoenix operating system. And in a user folder, I add the additional folder is a server uppercase. So this is a source code. It's a main C file. And I show you how I create this server. So look that the first I use only one special file. So I create one object ID. Look that if you need more than one special file, you need to create a one port and share this port through the all object ID created by the server, and the object ID differs only the ID. The value of the ID, it's your decision which value is assigned to the ID. And if you create the special file, the special file is connected with the object ID. So the ID identifies the special file. Okay, so I create a port, create the object ID with ID 0, create a port in here, and create a server uppercase special file using that object ID, and execute the message loop. In the message loop, I did the same. So the parameters is the same, but additionally I use the buffer. In here I declare the buffer and set the buffer length to 0. So look that this struct is defined in that place. So this is a data, this is a buffer size, and this is a length of the buffer, number of characters stored in a buffer. And I use this buffer to store the context of the special file. And look, that is the same. This is an infinite loop. I receive a message, and next I handle the open, close, read, and write. Open and close is handled the same way because there is no difference. Always is possible to open and close a special file. So look that this function is in here, is without changes. And two additional files is a message read and write. So additionally, I pass one parameter is a pointer to the buffer. Because if we try to read from a file, from a special file, so we read the data from a buffer. If we try to write, so we write a data to a buffer. And look that now I show you how I implement this in a read and write function. This is a read and this is a write. So look that first, of course, we print a diagnostic message. And next, we check if the len, if it's a number of bytes to read, it's greater than buffer length, that the number of characters stored in a buffer. If it's true, so we set the length to the number of elements in a buffer. So we limit the number, the bytes to read to the buffer size. And if the len is greater than 0, we try to read the value from a buffer. So we copy the data from a buffer to the data, to that buffer passes parameters, a pointer to the buffer, and copy the len bytes. And next we update the internal buffer. So we subtract the len characters from a buffer len, and if it's necessary, we move the rest of the data in a buffer to the beginning of the buffer. So this is a very simple operation. And next I print the diagnostic message. It's about the data read from a buffer, and this is a current buffer context. And look that we return the number of characters read from a buffer. So it can be less than the requested. And the write function, write the data to a buffer. So this is a diagnostic message, of course. And next, look, we go through all characters, which we need to write. So the len is a number of characters to write into the buffer, into the file. So the I change from 0 to len minus 1. And first we check is that character is alpha numeric, so we convert that to uppercase and store this character in a buffer only if in a buffer is a place. So if in a buffer is an empty place, so we stored the next character into the buffer and change the letter to the uppercase. After that, we print the diagnostic message. It's a context of the buffer. And we return the number of characters written to a file. And it's all what I need to do. So now I show you how it works. So I try to build that version of the disk image of operating system. So it consists of the new server uppercase, and I show you how this server uppercase works. Okay, it's done. So now I run the Phoenix. Look that there is a server uppercase program started at the system startup because I add this in a configuration file. It's a normal application. And now I show you that in a dev folder, there is a special file, server uppercase. So now I try to write few characters from A, B, C, D to that file. Look, it's done. So this is a diagnostic messages from a server, and now I try to read from that file. So I not echo but cat, and it's a dev server uppercase. Look that if I perform this operation, try to read from a file, so this is sent to the message to open that special file. Next, to write 5 bytes, so the data is written into that file. This is a data and this is a context of the buffer. And next, because it's a all, so the system, the echo send the close to the console, send the close message, so it's close the special file. And next we try to read from that file. So look that we try to read 4 kilobytes. So it's a request, open this file, next read 4 kilobytes. But in a buffer there is only 4 bytes. So the read function, the server, return the information, oh, I read only the 4 bytes from this file. And the buffer now is empty. So the cat program tried to read the bytes from this file. Again, it's a 1020 bytes. So it's not possible. The readed bytes is 0. And next, the cat program tried to read the 4 kilobytes again. And the return is a 0. So this program decide, oh, there is no data, so I close that file. So it's finished. And now this is a result. So look, this is the same text, but with uppercase. So it works as I expected. And what happens if I write more characters than there is a buffer size? So to show you how it works, I need 2 additional consoles. So I try to open the additional console. This is a second one. And I try to connect to the Phoenix. Okay, and another one. Okay, so this is one console and the second and the main one. And look that now I try to send to this file more than 16 characters, so it exceeds the buffer size. So I use the echo program and maybe letter will be better. So there is more characters than 16, so it exceed the buffer size, and I send this to the special file server uppercase. So look that now this echo program try to save this data into that special file. So the first 16 characters is stored in a buffer, and the echo program try to store the rest, start to write the rest, and it's not possible because the buffer is full now. So in a second console, I try to read from that file. So I read from a server demo special file. Server uppercase. And look that now I receive all characters. What happens? Look in here. So this echo program try to write a data, write to 11 bytes into the buffer. So this is not possible because in a buffer there is a 16 characters, the buffer is full. And now another program, from another console, I try to read from that file. So the special file is open. So it's right, and this is an open, and this is a read because the write is from that application, that console, and this console, this cat command try to open a file in here and try to read from a buffer. So it tried to read the 4 kilobytes, but the server return only the 16 bytes and the buffer now is empty. And next, this program tried to write the 11 bytes. So because the buffer is empty, it succeeds. So it returned that the data is written into the buffer. And look that that program read the rest. Try to read again. Read 4 kilobytes. So in here it's 16 bytes and here read the rest. So it's 10 bytes. And look that at the end, if we try to read the information, so this is a data read it from a buffer. So it works correctly. And this way you can create the server in a Phoenix operating system. So for my groups, the task is to create a server which create a more than one special file to encrypt and decrypt data. So if you need to create more than one special file, you need to, for a server, the server should create only one port, and port is an entry point to receive messages, and need to create few object IDs. So please remember, then you look, it's done in a main function. So we need to create the object ID, and object ID consists of the port and the ID. So IDs are unique within each server at this value, this identifier that identifies every special file created by the server. So you should use only one port per server is enough. And look, when you receive a message, so if we receive a message in here, in the message there is a type, and look that the message has a object ID. So we have an access to the ID value. So you can identify the file and perform an action on the correct file. Do you have any question about that? Okay, if there's no questions, so thank you for attendance, and try to do an assignment in during the laboratory. Thank you. Goodbye.